Hello everyone, my name is Alisher Mirgayasov, and in this presentation I'm going to discuss the work I've done in the course EIE3105 Integrated Project. So for demo 1, I used my personalized encoding system. So as you can see on the picture, basically based on the values obtained from the buttons, pressing buttons, or for example, using joystick, I've sent the characters to my car. So basically, if I pressed, for example, the button up, I've sent the capital H character. If I press the button right, I sent button H, the character H, I mean, and based on the values obtained from joystick from the left, I've sent multiple values. So a few of them are listed below. For example, if it's up, then it's U. If it's upright, then it's this curly bracket to facing right. And if it's down, then it's lowercase d. So for demo 1b, I used a pretty much straightforward approach. So I was just reading the values from the ultrasonic sensor and using the formulas which were given in the useful programs folder. I used those formulas, and based on them I calculated the following the basically the length. So for demo 2, I used the decision tree approach. So basically I've split the entire process into the set of cases. So you can see the most important cases listed here: case 1, case 2, and case 3. So basically for case 1, if it's, for example, if it's in the middle of the line, if the line is located in the middle of the car, basically, which means that one or the first or the second central photoresistor sees the black line, that means that car will move forward. So for case 2, basically it's rightmost or leftmost photoresistor. If it sees the black line, then it moves either right forward or left forward respectively based on the reading. So for case 3, it basically means that the car lost the track, and it tries to get back on the track based on the photoresistor where it saw the line last time. So this approach is actually quite simple. So the most challenging part was to choose the most proper values for the velocities for each of the motors, and basically differentiate the cases based on the readings from those photoresistors. So for demo 3, we needed to make our car stop basically right in front of the wall. So the closer it to the wall, the better. So again, I used the decision tree approach. So I've split the entire demo into 3 different cases based on the distances. So one is like the shortest distance, the medium distance, and the longest distance. So based on them, I set up different values for encoders for PWMs for each of the motors. So in each case, my car has started very fast, and then it's slowed down, and then it's eventually stopped. So basically, this allowed me to achieve a very, very effective performance. I'd say it's one of the fastest cars in the EIE3105 course. So for demo 4A, we basically needed to use the codes we had from demo 1 and use them to basically play with the ball. Hit the ball 6 times, 3 each. So the point of this task is basically to find the possible flows, the execution flows of our programs, and to basically test it in practice so we could successfully finish it too. So in demo 4B, we needed to combine the codes we had for demo 3 and demo 2. So in order to make the basically line tracking car, and so that it would perform some tasks based on values from ultrasonic. So as we already had the codes existing, we could just combine them and make some logical statements so that we could only one of the cars should perform the tasks only when it sees the other car coming.